All right, so let's look at these. How would we solve this if we have the variable in the exponent? So we said on the previous page, if you look at that flow chart, we said if I can replace this number with a power of 5, then I can easily set the exponents equal to each other. So can I replace 125 with a base of 5? 5 to the what power is 125? 5 cubed. So this is 5 to the 2x plus 1 equals 5 to the third. Since we know the bases are the same, what does that mean about the exponents? Yes, they're equal. So now I can go ahead and solve. Subtract 1, 2x equals 2, divide by 2, x equals 1. And if I plug that 1 in, always when you solve, you can always check. So 5 times 2, 5 to the 2 times 1 plus 1 equals 125. 5 to the third equals 125, and that's true. Okay, you can check that. You can use your calculator to double check that if you want. Let's go in order. So let's look at F next. Can I replace 115 with a power of 8? No. So what would I do? What would be another way to solve this? Exactly. So there's two ways you can think about this. Log base 8 of 115 is equal to x, because remember the log is always equal to the exponent. I probably have said that 100 times, but that's my job. I'm a broken record. That's my profession. Okay. Another way to think about this is anytime you want to get the variable out of the exponent, and by the way, that's solved for x. That's a number. If you put that in your calculator, that's log of 115 over log of 8, or use your log base. Okay, that's your number, whatever it is. I don't know what it is. Here, let's find out. But I was going to show you another way to do it as well. So we're going to have log of 115 divided by log of 8, and that gives us x is approximately 2.282 rounded to 3 decimal places. I believe it said on the last page to round to, oh no, it says round to 2 decimal places. Okay. Well, anyway, it's approximately that. Again, if I wanted to use my calculator to check and see if that number is correct, I could go 8 to the power of the answer, and then I get 115. But essentially, every time you have a variable in the exponent, you can always think about it like this. If I take the log, I can do whatever I want so long as I do the same thing to both sides. If I take the log of both sides, I would have log of 8 to the x equals log of 115. Is that legal for me to just take the log of both sides? Yeah, I did the same thing to both sides. So what happens to this exponent? Oh, the exponent comes out in front, so I get x times log of 8 equals log of 115. How do I get x by itself? These are just multiplied, so if I divide by log of 8, I get x equals log of 115 divided by log of 8. And that's the exact same thing I got when I did the change of, that's basically proving the change of base right there, right? This one right here was change of base. Change of base. That was the formula we went over for those of you who don't have the log base in your calculator. Okay, and I did a calculator check. All right, 2 more. We first start asking ourselves what question? What are you asking yourself when you look at this? Can you make the bases the same? Can you make 8 have a base of 5 very easily? No, you can't. No. Okay, so then we can use the definition of logarithm to say I would have log base what? 5 of what? is equal to, because that's the exponent. Okay, so log base 5 of 8 is just a number. There's no variables here. So what am I going to do to this number to get x by itself? Add 3. So now I have log base 5 of 8, which is the same thing as log of 8 divided by log of 5, plus 3 equals 2x. And now what? Divide by 2, and that will give me x. So on my calculator, just because even though I have the log base on my calculator, I don't really feel like going to that menu. So I would enter in my calculator log of 8 divided by log of 5 plus 3, and then take that whole thing and divide by 2. So I have log of 8, and you can do it in multiple steps, divided by log of 5. I could push enter. I'm going to add 3, and I'm going to divide by 2. You see how I just do that one step at a time on there? So now I get x is approximately 2.15. That's rounded to 2 decimal places. Why did I move the 4 up to a 5? I'm going to do a calculator check, and I'll show you what that looks like. If I do my calculator check, I'm going to plug in 5 to the power of, why not do parentheses, 2 times second ANS. Does everybody see where I'm pressing that answer button? Minus 3, close parentheses. When I press enter, what number do you expect to see on the screen? Woohoo! I know it's right, okay? If you put in 2.15, you're not going to get exactly 8, okay? I'll show you. 5 to the power of 2 times 2.15 plus 3. You see how, minus 3. Well, that's even, yeah, mine is way off. But I mean, if you do it more correct than I did, okay, to the power of 2 times 2.15 minus 3. Okay, there we go. 8.1. See, you're not going to get exactly because I rounded. That's why it's better to almost check it on the calculator. Okay? All right, what about this one? You have 30 times 2 to the power of x minus 4 equals 180. What should you do to solve for x first? Exactly. Divide both sides by 30. We're isolating. So I have 2 to the x minus 4 equals, how many times does 30 go into 80? 6. Okay. Can I make 6 can I turn 6 into a base 2? No, right? No? So what would you do? Yeah, log base 2 of 6 equals x minus 4. Good. What do I do to both sides to get x by itself? Okay, so your answer is log base 2 of 6 plus 4 equals x. Once you plug that in, log of 6 divided by log of 2 equals that, plus 4 equals that. I get x is approximately 6.58. I'll just go back to the beginning and plug that in. 30 times 2 to the power of this answer, which is the whole entire answer from above. Actually, even on newer calculators, you can sometimes scroll up to grab that answer too. Minus 4, all in the exponent. And that's equal to 180. So I did a calculator check. Yes.